All right, so we previously talked about the fundamental theorem of algebra, which says the degree of the polynomial tells you how many roots or solutions it has. And one way you can find those solutions is by factoring. So we're going to go through a factoring review. You've seen this before in Algebra 1, but we're going to come back to it now in Algebra 2. Just remember, factors are numbers or expressions that you can multiply together to get a certain quantity. For example, 2 and 3 are factors of 6 because I can multiply them together to get 6. 1 and 6 are also factors of 6 because I can multiply them together to get 6. In algebra, when we throw some variables in there, if I were to multiply this out, I would get x squared plus 1x plus 4x, which is 5x, plus 4. And so these two expressions are factors of this expression because I can multiply them together to get this. So it's almost like the reverse of multiplying. You have to figure out what two things can I multiply together to get this expression. We're going from here to here when we're factoring. There are many ways to do this. So just like with a bolt, it might take different sized wrenches to unscrew a bolt because there's different types of bolts. With factoring, it's going to take different strategies depending on basically the size of the polynomial. The first thing you want to do is always look out for a GCF, a greatest common factor. If you can factor out a GCF, it's best to start by doing that. You also want to look out for polynomial identities, which we're going to talk about in later videos, so don't worry too much about that one yet. And then after you look for that kind of thing, what you want to do is base your strategy on, does it have 2 terms, 3 terms, or 4 terms? This video is just going to look at factoring out a GCF. So let's just go through a few examples. As a reminder, GCF stands for the greatest common factor. So you're going to look at each term's factors, see what they have in common, and what's the greatest amount that you could basically bring out from each term. Like on this first one, notice that each one of these 3 terms could be divided by 3. That's the greatest number that I could divide all of them by. I can't divide them all by 9 because that doesn't divide by 9. So I could divide them by a 3. And then what's the most number of x's that I could bring out from each term? This one has 3, this one has 2, this one only has 1. So I can't bring out 3 x's because this one only has 1. So the greatest amount of x's I can take out would just be 1. Then, in parentheses, I'll write down what's left over when I take out the 3x from each of these terms. Basically, you're dividing by 3x. And divide this by 3x, and divide this by 3x. Here I divided out the 3, and x cubed, take out an x, would be x squared. Here, 27 divided by the 3 is 9, and x squared divided by x is x. Finally, negative 9 divided by 3 is negative 3, and x divided by x is just a 1, so the x is gone. So this right here, this 3x, is my GCF, and this is what's left over after I factor out the GCF. This may continue to factor, but for now we're just going to stop there. And I want to point out that this is basically the opposite of distributing. Like if I were to distribute 3x times x squared, I would get 3x cubed. 3x times 9x is 27x squared, and 3x times negative 3 is negative 9x. So I checked my work here and make sure I got back to the original. All right, next one. I'm going to look for a GCF, so I like to start with the numbers. I've got a 5, 25, and 30, so what could I divide them all by evenly? The greatest thing would be a 5. And then this one has x cubed, this one has x squared, but this one doesn't have any x's. So I can't take out any x's from my GCF at all. I'm just going to have to leave them. So in this one, the GCF was just 5. That's going to leave x cubed. If I divide this by 5, I get 5x squared. And if I divide this by 5, I get 6. So there's my GCF, and here's what's left over. And again, if I were to multiply this out, I should get back to the original. Go ahead and try these two on your own if you haven't been doing that already. So hopefully you've tried those. The greatest number I can take out would be a 12. And the greatest number of x's, this one has 2, this one has 4, so we're going to have to stop at 2. So it's tempting to be like, oh, that one just disappears because I took it all out. But think about if you were to divide this by 12x squared, it wouldn't be a 0, it would leave a 1. So we do need to put a 1 here. And if I divide this by 12x squared, that leaves 3x squared. All right, on this last one, when I look at 5 and 12, those don't share any factors. There's nothing I could divide them evenly by. And then this one has x squared, but this one doesn't have any x's. So this one actually doesn't have a GCF. It's already just kind of good to go. So this one has no GCF. Okay, if you want some more practice, here are a few more practice problems, but this is optional for you.